I'm starting recording. Hey, Anthony, welcome. Welcome to this event, and
Hello, Patrick.
happy you could make it.
Thank you.
So I'll let you start.
Okay. So today I would like to talk about a new method to do business analysis. At Aldesis, we have been working on it for many years, 5 years of research and development. And it is a new way to do, we call it a risk and opportunities reporting. To talk more about me, so I am a chief AI officer at Aldesis. I have been doing data science for 5 years. Before that, I was a CFO, so chief financial officer in the public sector in France. And I have been publishing many data science related content over LinkedIn and Medium. And since then, it has been 2 years that I have joined Aldesis on this project, on this adventure. So what we are using neurosymbolic artificial intelligence for decision making. What we have understood is that to do a business performance analysis, the artificial intelligence allow an organization to automate the detection, the discovering of risk and opportunities, what we call early warning signs. And by doing it with a method that we use, we spot 7 times more insights than by human exploration. So the question is no longer where to look at. It is the why question. The analyst and the artificial intelligence spot insights needs to understand the root cause of the problem. So it is a new role for them because we use artificial intelligence to automatically detect anomalies within the company's data warehouse. The new role for the analyst is to find the root cause. And for that, what we are leveraging are artificial intelligence in form of generative AI combined with symbolic AI in form of knowledge graph. So it is to find the root cause, and once you spot the root cause, our method allow also to help the analyst build a corrective action plan. So it is the whole question, how to react quicker than your competitors and to act on those root cause that our method allow to detect. So our approach, its main goal is to find opportunities even in a troubled business unit, okay, and improvement points in successful ones. Because even your best business units have improvement points. And I will show how we are doing that.
Mm-hmm.
Okay. What I ask our clients is this. Why in 2023, no business intelligence software is able to proactively detect anomalies? Why? Is it the end user, the analyst, to manually that he has to manually do a multidimensional to do an analysis? Why we don't use artificial intelligence with massively parallel processing to detect proactively anomalies? This is the first question. And usually what I ask also to clients is this. From your reporting, we can take, for example, September. Do you know how many insights were identified? And generally, the answer is no, because this is a KPI. It is not a KPI that is analyzed by companies. And even imagine if we respond to this question, yes, how many of those insights did you convert into corrective action plans? And we can go even further. From those corrective action plans, what is the trend curve of correction rate of insights into action plans? Those questions should be the KPI of any reporting system. Yet, currently, in many companies, they are not answered, they are not followed. And it should be the main goal of any reporting tool currently. And we think at Aldesis that artificial intelligence is paramount, is essential to answer those questions and help a business answer those questions and follow these main KPI. So, what is the main problem of current reporting tools? The main issue is consolidated analysis. All current reporting are built on consolidated analysis of data. Why is it a problem? I will show you a simple example. Right here, we have two continents. Okay. What you can see at the consolidated view is that continent 2, it's in a worse situation than continent 1. But if you deconsolidate, okay, what you can see is that for continent 1, that seems better off, there is an anomaly that is compensated by other countries for this continent. This is the problem of consolidation, because consolidation, you have multiple mathematical phenomena like Simpson paradox, like when you mix, there is a compensation between negative value and positive value, but even in positive value, you have a compensation. If you have an extreme positive value and the other value are smaller in comparison, this is extreme positive value will be hidden, will be masked by consolidated data, by consolidated value. This seems a simple problem, but it is not, because right now every reporting tool consolidates data and don't have a comprehensive and systematic way to do a deconsolidated analysis. And it is also true in time dimension. Right here, I am showing you an example where I am analyzing the current year and I compared it to the previous year. So I am in 23 and I am comparing 22. I am studying what we call in business finance the year to date. So I am analyzing the situation. We are in October, so until October, and I'm comparing the situation from the previous year. So right here in my reporting, what I observe is that I am better off in 23 comparing to 22. But this consolidated time analysis, behind that, you can have multiple situations. Okay? It might be that the current situation is explained by an anomaly, a positive anomaly. Right here, you can see an outlier, a quarter outlier that is explaining the current better off situation of my current year to date. But it can also be that my positive trend is degrading, is decreasing. Okay? But you can also have a tendency reversal. So you were better off, you were improving during until the third quarter, and after you are degrading. Those multiple, and I only took 3 examples, but there is many configurations. All those examples show that you need to deconsolidate even time analysis. So you need to add dynamic technical analysis within your reporting to analyze the trends and the dynamic of your data. So, and another issue that is, I am stacking up problems. So for you to understand what is the current issue of reporting. Another issue is that to have an insight detection solution, you need to do a systematic multidimensional analysis. Okay, I will show you an example. Right here, I am taking the client dimension. In line, I have products, but every of those lines are consolidated. Okay, so here the situation appear to be good. Okay, all are positive, all is fine. Okay, I am taking now the product dimensions. In every line of my client dimension for the product dimension, all are consolidated and positive. But what happens if I combine the two with those same data? Here, with only two dimensions, it is only to illustrate the necessity of multidimensional analysis. With only two dimensions, I can spot problems. And now imagine to do that with a 4, 5, 6, 7, 8 dimension. Right now, most of multinational companies, big companies, have built OLAP cubes, multidimensional data warehouse. So they are able to do those multidimensional analysis, but it is impossible for human. Okay, human can only do up to 3 dimensions on a spreadsheet. So you need artificial intelligence to do this in a systematic and automated manner. Yet, not many companies, not many solutions propose that. Okay, and yet it is necessary to spot insights. Okay. Right now, what is the situation of reporting, of the reporting world? What current reporting tool can see is this. It is a global vision, a reporting, a consolidated view vision, what we call a top-down approach. So what they spot is what we call flush head. Flush head are rotten branch. They are problems that are so important that they are coming up, they are affecting the consolidated view. Okay? But when you spot them as a consolidated level, it is too late. Because what you should have done is to spot them when they first appear. Before they were so big that they were affecting the consolidated view. And what those reporting doing consolidated analysis are not showing you, what they can't show you, are pockets of insights and golden nuggets, what we call them. It is a metaphor, but those are insights that are impossible to spot at a consolidated view. Why? Because there is compensation effect. They are concealed within your reporting. You can't spot them as a consolidated view. And because you don't look at the most granular optimal level of data analysis, you can't spot those insights. And what we found with our solution, with our experimental work, is that 85% of insights are currently not found by traditional means of reporting, by manual means of reporting. When you use artificial intelligence to do that in a systematic way, you find up to 7 times more insights, more anomalies within, for example, a business reporting for a large corporation. So it is like we are comparing it to an iceberg of ignorance. I don't know if you know the management author that told about that, but it is like you are ignoring most of the problem that you have. Okay. So, how can you tell that the approach that we are proposing, and I think we are not the only one to propose to propose a solution of insight detection. But how can you tell that our solution is better than others? Okay. There are 3 criteria. Like I said, I think that you need a multidimensional analysis because no human and no human are able to do it. And you need artificial intelligence to do that in a systematic way because you need a multidimensional analysis. You need to compare product, geography, time, region, etc., to spot anomalies, to detect early warning signs, to act on them quick and quicker than your competition. But what happens when you do that is that you are overflowed by alerts, okay? Because you are spotting 7 times more insights, the user will be overflowing by alerts and anomalies. And what you need to introduce is some sort of priorization. So you need to build up a priorization algorithm. What will be within this priorization algorithm? For example, the strategy of the company, some notion of urgency, some notion of feasibility, some notion of whatever. We built with an university a priorization algorithm that we can personalize to the company focus or strategy, because you need to tell the user with this what are insights that are high priority level, what are the most impactful insights. And what you need also to do, you need to find the most optimal granular level of analysis. And it is more simple to say it than to find it. So you need a method. You need to find the right level of analysis that you can compare across time. Okay, because if you go too low, too below a certain threshold, you won't be able to compare it over time. So you need to find a perfect granular level to do your analysis. And artificial intelligence can help also with that. So those, what I just explained, those are the problem of current reporting. What we have built at Altesis is a solution to solve those problems and to give tools to a company to have an early warning sign detection tool. So now I will talk about our data quality approach. Right now, our solution is based on a use case for business finance. So we use finance data to detect anomalies. So it is a batch processing tool right now to detect insights every month, because finance data is every month. And why we chose this approach? It's because finance data generally its quality is better. Because there are lots of regulation around finance data, because you got the taxpayer, it wants its money. You want auditors. Auditors want certain certification around finance data. Shareholders also want a good quality of finance data because they want to know where to put their money. Okay, so for the first part of detecting insight, we use finance data. Once we found insight, what our tool is proposing is to find the causality of those insights, because insights are just symptoms. Okay, there will be anomalies within a data warehouse. So, and anomalies, symptoms, is not forcibly a problem. You need to find the causality, the why, for you to know if you need to act or no. So right here, we are helping the analyst in his new role, because this is a new role for analysts. Most analysts in large corporations are only doing the first part, the what. But the what, like I just said, we automate it with artificial intelligence. So we need the user in his new role, and we think that its new role is in more. It has more value, much more value than the first one. The second one is much more complicated, and right here, what we use is generative AI, but not just only generative AI. We have built a RAG system, so retrieval augmented generation. That is a system that uses data to help the generative AI generate its content. And where we get our data, it's from operational data. So the problem with operational data is that you got quality issues. Some talk about data swamp in many companies, because you got heterogeneous data, quality inconsistency, inaccuracy. You got because if you take also external data, you will got biased, one-sided, half-hidden data. You are in a VUCA world, okay? VUCA, it means a complex word, uncertain. So generative AI will be here only to give you methodologies, to give you what is currently available. We are here in using artificial intelligence to build a collective intelligence. So it is to help the user build an action plan and not build for them the action plans, because here it is too complicated to automate. So artificial intelligence is only able to help the user find information. And what we like to do is that here we are more in the data science side. And here, in this part, we are more in a decision science side. And decision science side, you got psychology, you got information that are not present in the data, in the internet, in the data warehouse, in the structured data, etc.
Anthony, so one question: are you going deeper into the algorithms, or I can ask my question here?
I will, in the subsequent slide, I will go deeper, yes.
So I will be patient.
I am doing in a step-by-step manner, okay? So what we use. So I would like to show you our stack of artificial intelligence. So we use machine learning, supervised and non-supervised machine learning for the detection side. Okay, time series. We use also XGBoost to predict values from the detection part of our solution. Like I said, we also use generative AI. So what we do, but I will show you right here. We combine generative AI with knowledge graph. Knowledge graph that are built on operational data from our clients. And we also use knowledge graph to inform the generative AI of some sort of methodologies. For me, it is an alternative of fine-tuning. I much more better build an effective knowledge graph that gives, that can, when you have an ontology or operational data, than fine-tuning a model. Because fine-tune, you need, with time, you need to retrain your model. Knowledge graph is more easier to up-to-date, to improve over time. And what we have also, we have some parts of reinforcement learning. The reinforcement learning part, it's more for the super priorization, the priorization algorithm that we use. And I will show the actual app just after this slide. This is the data science side, okay? And what we have on top are symbolic artificial intelligence. Because our prediction from machine learning, supervised, non-supervised, use in the detection side rule engineering expert system. So we combined a connectionist with a symbolic artificial intelligence. And I will show you just after this slide how we did that. So, and the second part is decision science. We have a natural business analysis, explainable intelligence that explain what is happening in our app, that inform why this insight has been prioritized, etc. And we have what I have just said, a virtual collective intelligence, what we call a process intelligence that helps the user build his action plan. So right here, we have an escalation, a hierarchy of explainability, because those parts at the bottom are not that much explainable. And more you come up this line, more they are more explainable. So we use symbolic AI to have an explainability within our stack of artificial intelligence. And I will show you how it happened in the solution. So what are the symbolic AI that we use? We call them trackers. Okay. Trackers are specialized analysis. So like I just explained earlier, we have the mountain of data. What we do is that we exploit this mountain to have small granular slices of data. And for each slice of data, we do a systematic multidimensional analysis. And to do this systematic multidimensional analysis, we use some sort of rules, because you need to know where to look at. And currently, our use case is built around business finance. So our trackers are here to simulate best practice, SOTA, a state-of-the-art practice for business finance analysis. And what happened is that we have two types of trackers. We have trackers that are mathematical and business. Mathematical are here to spot mathematical anomalies. Okay, for example, a gross revenue increasing significantly above its objective. Okay, it is a threshold that we put that is best practice to analyze corporate data, and it will spot this threshold automatically within granular data analysis. But we get also business trackers. Business trackers are more a specialized rule for to do corporate finance. Right here, I put an example of gross revenue increasing plus net revenue decreasing. It is an anomaly, okay? If your gross revenue is increasing and that your net revenue is decreasing, is that you have a problem, okay? So we spot automatically, and we have 100, just here, I just shown you 2 examples, but we have hundreds of those trackers. And we can, with our clients, build more, okay? Imagine that our client have some sort of strategy or some sort of specific problem. We can build with them those type of trackers. So these are the symbolic part alongside knowledge graph. So what I have just said until now seems very complicated, okay? But what we aim for is lean reporting. We want our app to be in one page, okay, with 2 parts. We want a part that shows the risk and opportunities found by artificial intelligence. Right here, in the first part, you got overview. So we show the user what it is used to see, consolidated data, okay? Generally, in Power BI, for example, reports, you got consolidated data, and the user can drill down, okay? That's what happened in most reporting. Here we show the consolidated data, but below it, we show where to act. Okay, what are the top insights? And right here, you got a list. So you got a list. What are the most important insights individually? And for each of those insights, there were a multidimensional analysis, and those are granular slices of data that were systematically analyzed and compared. And you got on the same line, you got a trained analysis. Okay, so we do a dynamic analysis. We show the user where this product, for example, is going in the next month. We show a risk. This is the risk of not attaining the budget target. Okay. We show the influence of outliers. If this result was explained by outlier, and we show effects. Effects are the mix of price and volume. Okay, something can be explained by an evolution in price, but also by an evolution in volume. So we show that in this visualization. So this is the first part of our application. The second part, it is the interpretability part. What we use old-fashioned natural language processing combined with generative AI to explain for each of those insights. So I have just to click on it, and I will get a full explanation of why this insight has been prioritized. I will get also a comparison with other products, etc., etc. For the analyst to know why this insight has been prioritized and to be explainable, because we are using artificial intelligence. So what I am telling you is that our solution don't mean to erase the current way to do standard reporting. What we are building here is a boost, is a complementary, is a more effective way to do traditional reporting. And it is complementary in many ways. So if we compare the ability to give an overall picture, a big picture, our reporting is not able to give a big picture, even if we show the consolidated view, but standard reporting is more able to show an overall picture, a big picture, okay? Does the standard reporting do a complete analysis? No, I have just shown you. Standard reporting don't do a multidimensional analysis, don't deconsolidate. So our solution is able to detect early warning signs, to detect problems when they happen, and the fastest way possible. And they do it in a systematic way and with a prioritization algorithm to do that. Is standard reporting a guidance on where to act? No. Standard reporting in most companies are forests of reports, and you don't know where to act. You need to do manual digging. It's like fishing, manual digging. And human, to do, for example, a drill down approach, to deconsolidate manually, it takes time, and it is a guessing. It is an arbitrary way of analyzing data. What we do is that we automate, and systematically with parallel processing algorithm with CUDA calculus, we automate the systematic way of de-averaging, multidimensionalize the analysis. So in terms of dimensional analyze, with standard reporting, you can go to up to 3 dimensions. More, you can't show it visually. You can't show it in a Power BI, in whatever, in an Oracle. you can't show more than 3 dimensions. With our solution, this is why we don't show visualization in this way. We do unlimited amount of dimension at the same time, in the meantime. As many as the management accounting, for example, for our use case currently carries. But what is useful with current reporting is that it gives you where to demobilize. Because once you spot an insight, what the high level management will want to do is to move resources on those insights, to deprioritize maybe some other projects that are not a priority thanks to our analysis. So this reporting can help you know where to act in this regard, where to demobilize resources. So this is the second part. Once you spot insight, what we are building is generative AI to help the user build an action plan. So I have my insight, okay? I am the deep detect, we call it, the first module, detect an insight. And I want to build an action plan with deep root. This is the second module that we got. And what we did is that we built a methodology to analyze a problem. Okay, what we are spotting, we do in a multi-step way a methodology to analyze this problem, and we are combining behind the hood a generative AI with knowledge graph to do that. So the artificial intelligence is here to ask questions, to spot information available, but also to spot information that are necessary, but they are not available. So what we would like to do with that is to induce some sort of Gamba walk, some sort of questioning, some sort of inquiry to prepare the analyst to do a business plan and to show that at the actual meeting that will decide prioritized project. So we are making a bridge between the reporting world and the project management world. In most companies, those two worlds don't talk with each other. So we are building a bridge between these two worlds. And we are building also a process intelligence. In the app, you have a view of what artificial intelligence you use at which step, because we are simulating what I didn't explain is that we are simulating sparring partners. So I am simulating a marketing director. I am simulating a financial director. So obviously each of those artificial intelligence will have access to the specific data of his domain and will be able to help the user build some sort of process intelligence. Maybe in the risk opportunity scope, you talk with the marketing generative AI, and after the context change, when you analyze the context that has been changing with the supply manager, you want to go back to the risk opportunity scope and to talk with the chief financial officer. Okay, what we are building here is not to automate. We are here to help the user find information and build something. Okay, and we found that generative AI is not here to help user do, for example, text to SQL, help them ask questions to a data warehouse. They are here to help to ask, to have methodology, to help them get methodologies, to help them find information. In this way, they are far more effective. So that was it, my presentation.
I have lots of questions. But...
Yes, no problem.
Because how did you train the model?
Yes.
Did you train a model, or are you using standard kind of? For the generative AI part.
Okay. For the model, currently I am using because I have no choice because I am leveraging knowledge graph. I am using 3.55 model of OpenAI.
Okay.
It is a necessity because it is the only model that is not that much costly and is able to querying in Cypher knowledge graph. So. But what I want and what I am looking for currently in terms of development is to leverage, for example, Zephyr 7B or that sort of open source model to do that. But currently, I didn't see in the research papers any evidence of such capabilities. I didn't have time to fine-tune an open source model or this.
Oh, okay. But then for the insights, you're using anomaly detection more, right? Mostly.
Insight, no, because what we are using, like I said, we are using a layer of symbolic artificial intelligence. Okay, we are using effectively a time series to calculate trends, and data scientists will tell me that I don't have enough data to do that, but we have some technique of data augmentation. And our solution overall is an anomaly detection, but we don't use an anomaly detection. We have an in-house algorithm that is proprietary. We are doing a patency, yes, claim. We have a Markov chain that is doing the priorization of insights. Okay. So the priorization that you saw behind the hood is a complex Markov chain to prioritize business problems.
Okay. And when you said we're using, I mean, this is interesting. Long time ago, when I started studying artificial intelligence, it was still called expert systems.
Yes, that's why we use it. Yes,
and this is very interesting to see that expert systems are coming back after probably 30 years.
They are. I think right now, recently a study showed that generative AI is more able to do text to SQL thanks to knowledge graph, where the knowledge graph have a database schema in it. So I think we are seeing, I am writing a lot about it. We are seeing some sort of neurosymbolic, what I call neurosymbolic system that are emerging. Because the problem with a pure deep learning approach is that deep learning is not interpretable. Or it is very, very much difficult to interpret. Yeah. And I believe that in most use cases, you need to have interpretability, an interpretation. Because artificial intelligence, its role is to, if you want artificial intelligence to be prescriptive, to prescribe action, you need a collaboration between what are the output of the artificial intelligence and the human. And to have this collaboration, you need some layer of interpretation. So,
and but okay, when you go to different clients, right, then you might have different rules, business rules. You might have different data quality. You have different semantics. You have different context. You have different everything, right? So
yes. So, Sisi, there are two questions in your question. For data quality, what happens is that our tool is so granular, is so multidimensional, that at first, what you are getting are lots of data quality issues. We are spotting anomalies that are not based on a business problem, but anomalies that are based on the quality issue. And we help the client deal with that because we are experts. My company has been working on this type of reporting tool for almost 20 years, and we are expert in dealing with those types of data quality issues. So we help them resolve their quality issues. So it is the first step.
But this is the first step.
It is the first step. And what you told me is that our current use case is corporate finance. So we, like I said, with Symbolic AI, we built methodologies to analyze corporate finance. But even for this use case, we can add specific trackers. Okay. Currently, we are working with a large multinational corporation in France, and we are adding specific trackers that are relevant of what they are doing right now with their data. So we can personalize our tool, because the machine learning part is instrumentary to the symbolic part. The main engine are symbolic. The machine learning part is instrumental. So it doesn't. It's not the main focus of the
symbolic layer at the top you showed.
Because our true innovation, if I put it bluntly, is not an artificial intelligence innovation. It is a methodology method of deconsolidating multidimensional, but it is only possible with methodology by parallel processing, massively parallel processing, and with artificial intelligence, to do it in a systematic and automated way.
Anyway, this is a dream, right? To be able to to get early warnings, to get early insights, to take actions, to make decisions. This has been a dream since I'm doing technology, by the way. So it's not new.
It is a dream, but we talk about my CEO talk about with high-level figures in the big corporation. Currently, reporting tools don't deal with consolidated problem because they don't have a solution. They simply don't have a solution.
Or they just used statistical kind of methods, right, to find insights.
Yes.
But then it doesn't. Yeah. But then you still need
to, like you said, to deconsolidate right now with a classical statistical method. There are nine methods to deconsolidate. You can use PCA, dimension reduction, etc., etc. The problem with those methods is that you can't do it systematically, and you need a data scientist to ask himself, oh, here there is maybe a problem, and I will do some sort of analysis. But it is too late, because when it spots the problem,
it's taking too much time. Yeah.
It's taking too much time. Yes. So our solution, I won't reveal, or we did it, obviously, but we take a surprising approach, a brute force approach.
Brute force approach. Yeah. Interesting. I don't know if there are more questions, but so it's quite interesting, because we see the application of not only generative AI but also standard machine learning. You spoke about XGBoost, right? So which is kind of standard machine learning.
Standard for database, yeah, for
generative AI, symbolic AI. So you're combining quite a lot of different
yes
approaches.
And for one page, because what we want is the simplicity of it. We want something to be funny. We are incorporating in the app a speech to interface, but I can talk to the application to show me what I want to see. We want something that is simple to understand, because we want to focus the analyst job, and there might be hundreds of them in our clients, to focus on building a solution to the problem that has been spotted, and not to build reporting, because the situation currently, most of the time of the job day of those analysts are building reporting, are spotting insights,
dealing with data quality, and
exactly. We want to automate that, and we think that artificial intelligence needs to be used to do that, because it is possible to do that in a systematic way. And we are not here to allow the user to ask any question he wants. Right now, a lot of builders are speaking about text to SQL, unlimited data on demand, etc. We think that artificial intelligence is much better than us to find problems in a systematic way.
And to help making decisions based on experience.
Yes. But to make decisions, we think that the human it's more better. To find problems, the AI is more better. To make decisions, the human is more better. But it can be helped with artificial intelligence.
But you can recommend actions that
exactly
before you. But you can also ask questions. For example, you can have the.
We see it as
to ask questions, right? Yeah.
It is interesting because we see a generative AI as some sort of recommendation engine. It is here to recommend action, but not to make action for the user. Yes.
A colleague of mine was showing me just this morning just a quick and dirty app about reporting, by the way. And then somebody was writing a report, and then the app was asking questions that the report was not answering, right? So, for example, I don't know, you have a project status report, and then you forget to mention a target date, you forget to mention this and that. Then the bot or the assistant will spot this and say, okay, what about when do you expect this to happen? You need a target, blah, blah, blah. So this kind of thing is really augmenting the intelligence of.
Yes, because I think generative AI is really good to process a lot of data and to intelligently to next token predict what is missing, what is generally present, and yes, it's really good. It's really good to do that. Like you just said, I use it a lot with tabular data frame, and I ask it what is missing from this data frame. Yes, it's very good. And we are using it for that. We are using it. What we are doing is that you are using it here in our solution for operational data, but not only for unstructured, for structured information, but also for unstructured information. We are putting in knowledge graph methodologies, a way of doing things, a way of doing a problem, a particular problem, etc., etc., to help the user to upskill the level of expertise of those analysts. Because for our use case, we have a problem of turnover for those positions, and a lot of analysts don't stay a lot of time within the company. So we are helping them also with for their expertise.
Merci. Thank you very much.
Thank you. Merci.
It was very interesting. Good discussion. Hope everybody enjoyed. So I will upload the video on YouTube and give you the links on LinkedIn and everywhere possible.
Thank you, Patrick.
And enjoy the weekend.
Nice to talk to you, and enjoy the weekend.
Speak later.
Ciao. Au revoir. We speak later. Au revoir.
Bye.
Au revoir.